It's another math day here with teacher Jenny. Join me for another topic. This time, we're going to talk about the alternative definition of your slope of the line tangent to the curve. So find the slope, intercept form of the equation of the tangent line to the curve defined by g of x equal to 2x minus 1 over x plus 1 at a point where x is equal to 2. Now this time we were asked to find the slope intercept, not the general equation or general form of the equation of the line. So when we say slope intercept form, if you still recall, we've got that as y equal to mx plus b, wherein you've got there your slope as m, your b as the intercept. So meaning to say we are going to make sure that we have the slope in which we cannot identify that one in a given. We also have our b. So, but anyways, we can come up with those missing information if we are going to use our slope using the limit definition. But this time we're not going to use the definition 2.1.1, but we are using the alternative definition for the slope of the line tangent to the curve, in which we have that as m is equal to the limit of your f of x minus f of a over x minus a as your x approaches a. Let us recall also that once we say a here, we refer to the x value, which is the point on the curve. So our a here is also our x. So this 2 here is our a. So rewriting our slope here, we have our slope is equal to the limit of your f of x minus our f. Our a there is 2 over x minus our a is 2 as your x approaches to 2. So our f of x, we just simply copy that one. But this time, if you try to look at this is our g of x. So instead of f here, we may change your f here into g, because take note, the f here is the name of the function. But if we try to change our function to any letter, other letter, we can also change this one here. So this one will become g of x, and then we have minus g of a over x minus a. So this one also is g of x. This one is g of 2. So rewriting that one, we have the slope is equal to the limit of our g of x. We just simply copy that one as 2x minus 1 over x plus 1 minus our g of 2. We don't have our g of 2. We need to solve our g of 2 first. So g of 2, since our x here, we replace that with 2, that will be equal to 2 times 2 minus 1 over x here is 2 plus 1. This is equal to 4 minus 1 over 2 plus 1 is 3. We have 4 minus 1 is 3 over 3. Our g of 2 here is equal to 1. So replacing g of 2 as 1 over our x minus 2 as your x approaches 2. So simplifying that one, since we've got here a fraction at the numerator part, and we have also another term, so we wish to have it into a single fraction so that we can simplify. So slope will be equal to the limit of 2x minus 1 over x plus 1 minus 1. The LCD of that is x plus 1. This will be the LCD of the entire numerator. So x plus 1 divided by the denominator here of the numerator, x plus 1. So that's a 1 times 2x minus 1. That will be 2x minus 1. And then here we have over 1 here on 1. So 2x plus 1, the LCD, divided by 1, that's x plus 1, times a 1 here, that's still x plus 1. So we have minus We enclose that in a parenthesis because we have a binomial, and then before that is a minus, so we have x plus 1 here. And then we have all over x minus 2 as your x approaches to 2. So simplifying, we've got a slope is equal to the limit. We have 2x minus 1. We distribute our negative inside, so we have minus x. And then we have minus 1 because we have distributed our negative sign inside x plus 1. And then we have x plus 1 over x minus 2 as your x approaches to 2. So simplifying the numerator part, slope here will be equal to the limit of 2x minus x, that will be an x. Negative 1 minus 1, that's a minus 2 over x plus 1 over x minus 2 as your x approaches to 2. So simplifying this one because we have still a fraction over or within a fraction, so we wish to have it into a single fraction. So let me just have it at the top here. Slope here will be the limit of your x minus 2 over x plus 1. We try to get the reciprocal of the denominator. Our denominator is x minus 2. This is understood with a denominator also, which is 1. So once we get the reciprocal of x minus 2, that will be equivalent to 1 over x minus 2. We just have to flip it. And then we proceed to multiplication. And then as your x approaches to 2, simplifying that, slope is equal to the limit of this one will be canceled, and so with that one, so we have that as 1 over x plus 1 as your x approaches to 2. This time we can now substitute. So our slope is equal to 1 over x is 2 plus 1. Our slope here is equal to 1/3. So since we have now the slope, we are going to look for our b. We don't have any means to look for b there. That is why we are going to use again the point slope form equation, because we have the point, we have the slope, we have the y value of your point, we have the x value of your point, and then we have the slope already. So we go back to y minus y sub 1 equal to m times x minus x sub 1. We copy y minus y sub 1 is, this one is our y sub 1, 1 equal to our slope is 1/3. And then we have times x minus our x sub 1 is 2. So we simplify. Since we have here a fraction, so we wish to simplify that one by simply multiplying everything here by 3, which is the reciprocal of this, so that that will be eliminated later on. So this will be now 3y. 3 times negative 1 is negative 3 equal to 3 times 1/3, that's 1. So 1 times x minus 2, that will be x minus 2. And then we wish to come up with this format wherein y is left alone on the other side. So we move minus 3 to the other side. So 3y will be equal to x minus 2. From minus 3 there, that will be adding 3 on the other side. So 3y is equal to x minus 2 plus 3, that's a plus 1. We divide this by 3, and so with this one here by 3. So our y here will be equal to x over 3. X plus 1 over 3, we can simply separate this numerator into two single terms. So we can have it as x over 3 so that our slope will be emphasized, and then plus 1 over 3. So the slope there is 1/3. So this is now our point slope intercept form of our equation of the tangent line to the curve. So I hope you learned something on that one. So kindly practice on that so that you will be able to be familiar with the process.